types of addition reactions. We have basically three types of addition reactions: electrophilic addition reactions, nucleophilic addition reactions, and free radical addition reactions. In alkenes and alkynes, common reactions are electrophilic addition reactions, whereas in aldehyde and ketones we have nucleophilic addition reactions. And in Anti-Markovnikov addition of HBr over alkenes, or I should say Carbocation effect, shows free radical addition reaction. So let us see these categories, what is happening over here. So if I show you electrophilic addition reaction, I will take an alkene and show you what actually is happening. In electrophilic addition reaction, I have, let's say, propene, where addition of HBr is happening. We have taken the same reaction so that you can understand. If HBr is taken, so the mechanism goes like this: we have CH3CH double bond CH2. Now H plus and Br minus are attacking. So in the first step, step 1, in the step 1, attack of electrophile occurs. That is why we have given the name electrophilic addition reaction. So what do you think? On which carbon the negative will be stable? On the carbon 1 or the carbon 2? I think you will agree with me that 1 degree carbanion is more stable than 2 degree. So the bond breaks like this, so that you get negative charge on 1 degree carbanion. So when negative comes on this carbon and positive this carbon, so negative attract H plus. So you get a carbocation like this, CH3CH plus, and CH2 becomes CH3 because H plus is getting binded over here. So you get this carbocation. In the second step, we had H plus and Br minus. In the second step, you have addition of Br minus. I think you will agree with me, there is no carbocation rearrangement happening right now because the most stable carbocation already formed. So Br minus will attach with this and you will get a compound which is known as 2-bromopropane. In this mechanism, there was a scientist whose name was Markovnikov. He gave very simplest form of this mechanism. He told the students that in unsymmetrical alkenes, what type of alkene is known as unsymmetrical? Alkene in which on both sides of double bond different groups are attached, such as this. Here on one side of double bond methyl is present, on the other side of double bond nothing is present. So this is known as unsymmetrical alkene. So Markovnikov rule is basically for unsymmetrical alkene. So what does Markovnikov rule say? Markovnikov rule says that negative part of addendum, the negative part of addendum attaches to that double bonded carbon which has less hydrogen atoms. I repeat, the negative part of addendum. What is addendum? Addendum is adding molecule. The negative part of adding molecule attaches to that double bonded carbon which has less hydrogen atoms. So in this alkene, I think you will agree that this is the carbon which is having less hydrogen atoms, that double bonded carbon which has less hydrogen. So negative will attach to this carbon and positive will attach to other carbon. So I think you will easily say the product will be that Br minus attaches to this double bonded carbon and H plus to this, and pi bond will be removed. So simultaneously you will get this product. I hope this will be very easy for you because I have explained the mechanism. Along with that, I have explained the Markovnikov rule, which is a kind of trick to do addition reactions over alkene. So alkenes show Markovnikov rule in unsymmetrical alkenes. Unsymmetrical alkenes where on both sides of double bond different groups are attached. If same groups are attached, it is symmetrical. So there is no requirement of Markovnikov. You can add negative and positive anywhere on the double bonded carbons. But if it is an unsymmetrical alkene, you have to make sure that you go by mechanism, because mechanism is universal. Markovnikov rule applies to, let's say, 98 to 99% cases, but 1% cases Markovnikov rule can fail, but mechanism will never fail. So always go by mechanism. But if you don't want to study mechanism, you use Markovnikov unless you hit something which is not following Markovnikov rule. So this is it for now. Thank you.